Hello, so welcome to question one of this resource. This is all about calculating percentage yields. Now, just so you're aware, if you are a combined scientist, so you're doing the combined science GCSE, you do not need to know this, okay? So you shouldn't be watching this video. Go away. There are other calculations that you do need to know about, but not this one. If you're still here, I assume that means you're either taking separate chemistry or triple chemistry, so you do need to know this as part of your specification. So let's crack on. This question tells us that when a student performs a reaction shown below, so the reaction between hydrogen and oxygen, they are forming 84 grams of water. And it was calculated that the theoretical yield of this reaction is 92 grams. Now, we need to calculate the percentage yield, and it also tells us to give our answer to a total of 3 significant figures. Now, the first thing is we need to know exactly what percentage yield is. Now, percentage yield is essentially a comparison between the actual yield, so what you are actually obtaining in a chemical reaction, and the theoretical yield. So theoretically, if all of your reactants were to be converted and you weren't to lose any of the products due to side reactions or practical losses, and assuming all of the reactant had reacted, what is going to be that theoretical maximum yield, that 100% yield? So in this question, it's telling us that we've got 84 grams being produced. So our actual yield is equal, in this case, to 84 grams. Our theoretical yield, it tells us in the question, is equal to 92 grams. So therefore, to find the percentage yield, what we need to do is it is a percentage, it's a comparison. So we take the actual yield, which I will abbreviate AY, and we're dividing that by the theoretical yield, which I'll represent TY. Now, because it's a percentage, we do need to multiply the answer to this calculation by 100. So if we substitute our numbers in, 84 is our actual yield, 92 is our theoretical yield, and we're multiplying that by 100. And if you do that, you get an answer of 91.304%. Now, this is a 2-mark question. One of the marks is for doing this calculation correctly, but the second mark is for giving your answer to 3 significant figures like it suggests. So the first significant figure is that 9 from the 90, then the second is the 1, and then the third is the 3 after the decimal place. So based on this number here, the 0, we're either going to have to round up or down. Because 0 is less than 5, we round it down. So our answer to 3 significant figures is 91.3%. Okay, so that's question 1A. Question 1B, a similar question, still looking at percentage yield. This time a scientist is reacting iron with chlorine to form iron chloride, and we're told that the actual yield this time, 3.9 grams of iron chloride, is produced. Okay, just so you're aware, that little 3 in Roman numerals, that just tells us the charge of the iron. So it's 3 plus is the ion in this case. So 3.9 grams, that is our actual yield. So I'm going to write that in just there. And it's already been calculated for us that the theoretical yield is 54 grams. So I'm going to write theoretical yield, Ty, is 54 grams. We need to calculate the percentage yield of this reaction. Again, we're giving our answer to 3 significant figures. So percentage yield is going to be equal to actual yield over theoretical yield multiplied by 100. Substituting the numbers in, we've got 3.9 divided by 54. We're multiplying that by 100. If you do the calculation, you put the numbers into a calculator, you'll get an answer of 7.222, so on and so forth, recurring. And again, we need to give our answer to 3 significant figures. So the first significant figure is the 7. The second significant figure is the 2 after the decimal point, and there's our third one, it's that 2 there. So what we need to do, look at the fourth digit, it's a 2, it's lower than 5, so therefore we're rounding down. So therefore, to 3 significant figures, the percentage yield is 7.22%. And the second mark, after getting the right value, is getting it to the right significant figures. Now, one thing that must be said, always look carefully at the question as to whether it's asking you to give your answer to the nearest whole number, to a particular number of significant figures, or to a particular number of decimal places, because it's an easy place to drop marks. Sometimes the examiners will be kind and put it in bold like they have here, but not always the case. So just make sure you read that question carefully and extract all the information that you need. Question 1C, a very similar question. It's another percentage yield calculation, but this time we're told how much potassium hydroxide is being reacted, and we're told that we've got 17.1 grams of potassium chloride being formed. Again, we need to calculate the percentage yield, but you'll notice we aren't given the theoretical yield this time. We're only given the actual yield. So we know the actual yield is equal to 17.1 grams. Theoretical yield, we don't know. We're going to have to do some extra work in order to figure it out. And in order to do that, you'll notice that we've been given the mass of one of the reactants, and we've also been given some relative atomic masses. Now, as is always the case in chemistry, if you're ever in doubt, what you should do is calculate the number of moles, because that is probably going to be part of your overall calculation. So the first thing we need to do is we need to figure out how many moles of potassium hydroxide we're reacting, because if we do that, we can figure out the theoretical number of moles of potassium chloride that we can form. So I'm going to rewrite my balanced equation just here, because I'm going to put all the information I need just underneath. So there's the potassium hydroxide. I'm going to ask myself the question, what's the mass of Mr. Mole Rat? If you don't know what that's all about, if you check the other videos on this channel, you'll be able to find one about calculating masses. So that's where that comes from. And we've got a mass of potassium hydroxide equal to 16.8 grams. Now the relative formula mass, that's what this is. So if you see MR, it's another way of writing relative formula mass of KOH is going to need to be calculated. So we've got one atom of potassium, so that's equal to 39. We've got one atom of oxygen, that's got a relative atomic mass of 16. And we've got one atom of hydrogen, so that's got a relative atomic mass of 1. So if we add all of those numbers together, what we end up with is 56. So in order to find the moles, we take the mass and we divide that by the relative formula mass. So 16.8 divided by 56. Now, if you do that calculation, you get an answer of 0.3 moles. Now, this would be the first mark in this calculation out of the 4. Now we need to look at the ratio, and the ratio refers to the molar ratio in the balanced equation. So you'll notice that in front of KOH in our balanced equation, there's no number there. So it's just 1 mole of KOH. It reacts with 1 mole of HCl in order to produce 1 mole of KCl and 1 mole of H2O. There's no balancing numbers, so that means the ratio is just 1 to 1. And if it's a 1-to-1 ratio, if I start with 0.3 moles of potassium hydroxide, it means that I'm going to finish with 0.3 moles of potassium chloride. That's going to be worth another mark in your calculation. So now what do we need to do? Well, we need to find the relative formula mass of potassium chloride so that we can figure out this theoretical yield, this mass that could be produced. And in this case, we need to take the relative atomic mass of potassium, which is 39. We need to add it to the relative atomic mass of chlorine, which is 35.5. If you do that calculation, okay, 39 added to 35.5, what you end up with is 76.5. And then you need to do 76.5 multiplied by 0.3, because we're going up this time rather than down like before where we divided. And if you multiply those two values together, you get an answer of 22.35 grams. That, what we've just calculated there, is the maximum possible yield of potassium chloride that could be made if we started with 16.8 grams of potassium hydroxide. Therefore, that is our theoretical yield. So that is equal to 22.35. Give ourselves another tick for getting that value. Now we just do the calculation we did in parts A and B. So therefore, percentage yield is equal to actual yield over theoretical yield multiplied by 100. That is equal to, this time, 17.1 divided by 22.35 multiplied by 100. If you do that calculation, you get an answer of 76.510%. And once again, the question has asked us, if you can see up there, to give our answer to three significant figures. So therefore, the answer is going to be 76.5% because this is our third significant figure, and this value here, that 1, is less than 5. So we're rounding down rather than up. There's one more question on percentage yield as part of this pack, and it's very, very similar to the last one we've just done. So we're told that we're reacting 64.8 grams of aluminium, that's one of our reactants, with an excess of oxygen, and the yield that has been obtained of aluminium oxide is 82.5 grams. So our actual yield is equal to 82.5 grams. Once again, our theoretical yield is not given to us. We're going to need to use what's the mass of our thermol rat in order to figure it out. So there's our balanced equation. We're going to write underneath mass, Mr, mole, and rat. And for aluminium, we're told that we're reacting 64.8 grams. Now the relative mass of aluminium is given to us here. It is 27, and it's not part of a compound, and we don't need to include this 4 because that's a balancing number. We're only interested in the actual formula of the substance at this point. So we're going to put our 27 in there, and what we're going to do is find the number of moles by doing 64.8 divided by 27. Now if you do that, you get an answer of 2.4 moles. Now this time, we look at the balancing numbers for our ratio, and you'll notice it's not ones this time. We've got a 4 in front of Al, so that means there's a 4 there. And we've got a 2 in front of the Al2O3, so we're going to pop a 2 over here. Now what this means is we've got a 4 to 2 ratio, which is the same as a 2 to 1 ratio, if we were to simplify it. That means that for every 2 moles of aluminium that's formed, only 1 mole of aluminium, for every 2 moles of aluminium that's reacted, only 1 mole of aluminium oxide is going to be formed. So that means we're going to have twice as many moles of aluminium as we do aluminium oxide. So if we've got 2.4 moles of aluminium, that means we've got half as much or half as many moles of aluminium oxide, which means we've got 1.2 moles because 1.2 is half of 2.4. Now we need to figure out the relative formula mass of aluminium oxide. Well, we've got 2 lots of 27 because there's 2 aluminiums in there, and we've got 3 lots of the oxygen, and the oxygen has a relative atomic mass of 16. So we're going to do 3 lots of 16. If you add those 2 values together, you get an answer of 102. So therefore, to find the mass, we need to do 1.2 multiplied by 102, and that gives us an answer of 122.4 grams. So that is our theoretical yield. Like before, you'd get a mark for doing this number of moles, a mark for figuring out the correct ratio, so the number of moles of aluminium oxide, and then another mark for calculating the mass of, the theoretical yield of aluminium oxide. Then we do what we set out to do, find our percentage yield, which is actual yield over theoretical yield multiplied by 100. The actual yield is 82.5 grams. The theoretical yield is 122.4 grams. We multiply that by 100, and that gives us an answer of 67.40196. But to 3 significant figures, once again, we're rounding to that value. So again, look at the question. It says 3 significant figures. So we need to round down because this zero, our 4th significant figure, is less than 5. So therefore, the answer is 67.4%. So that's percentage yield. That's the extent of the questions they can give you. To be honest, they're more likely to ask you questions like A and B, but it's still worth knowing how to do C and D.